Okay, so for about 10 objectives in a row, maybe even more, we've been talking about quadratics and we've been talking about parabolas. Now, moving on from 134, 135, 136, 137, everything we're going to do next week is going to be different shapes, not parabolas, not U's. But what we learned yesterday about how to take a shape, move it left and right, move it up and down, all that's going to apply to everything we're going to do from here all the way through next week. What we're doing on 134 is a square root function. And the parent graph is just basic y equals square root of x. Throw that in your graphing calculator really quick. That's the one and only thing I want you to throw in today is y equals the square root of x. Everything else, we're going to take this shape that you see, and we're going to move it left and right. We're going to move it up and down. We're going to flip it around.
Got it.
It just gets bigger as it goes.
Yeah. So, if you put in here square root of x, this is what you should be looking at right here. What I call this when I go to graph it, instead of a U shape, instead of a parabola, I call it a dot with a tail. The dot is right here on the origin, and then it just tails over to the right. Like Jacob said, it gets a little bit higher as you get out there. Right. So it's a dot with a tail. So let's sketch the dot with the tail on our parent graph. The dot on the origin, the tail right there. And the vertex, or basically the starting dot, is the origin. So the vertex is 0, 0. And what we're going to do is take this dot with a tail, and we're going to move it left and right. We're going to move it up and down, just like we did yesterday. Now the first thing here says a number outside. To be a little bit more specific, I'm talking about a number outside to the right. What did that do yesterday? Moves it. Like if I took a number and put like a +2 out there, what would you think that did?
Moves it up.
Moves it up or down. So a number outside to the right is going to move your shape up or down. A number inside, and if you kind of look a little bit ahead to this next example, this is what I mean by inside, is going to move it left or right. But just like yesterday, the inside is opposite. So this is left or right. But opposite the sign. So pluses go left for some reason and minuses go right for some reason, just remember. So before we do the first example, look very carefully at the parent. Here's the parent graph, dot with a tail, dot on the origin, we're going to move it. Let's look at the two moves. So we, instead of y equals the square root of x, you got this. What does this -3 out here mean?
You move it down right 3 or down 3.
Down 3, down 3. So just put a D3 or something right there. Down 3. And now this +2, that's your left, right. But +2 is going to make you go where?
Left.
Left. So an L2. So move that dot. Let's go left 2 and down 3. The dot that was on the origin. Left 2, down 3. Right here. Bless you. And then it's that same shape. It's the exact same as this. Just put it right there. And what's our vertex? Where's our starting dot at? The location?
No, wait.
Negative-
Negative 2.
Negative 2, negative 3. Bless you. All right, now we're going to talk about flipping it. Negative signs are going to flip it. If there's a negative outside, a negative over to the left, that's going to flip the thing left. So a negative outside, or wait, that's going to flip it down. Just like a negative outside flipped the parabola down, a negative outside will flip this down. So flips down. And your first, that's what this is right here. So if you have a negative square root of x, flips it down like this. Upside down. Now on this objective, like the actual problems you're going to do, you won't actually see this one right here. You won't see a negative inside. I haven't. I've looked at a whole bunch. But a negative inside flips it left. Just FYI, flips left. So if you had a negative inside, it would go this way.
Wait, what is that?
Flips left. A negative inside flips left. might, if you want, write them on here. Flips down. Flips left. And then let's look at another example here, where you have a flip. Okay, so here's your square root of x. The plus 4 makes you go where?
Up 4.
Up 4. This x plus 3, now notice how it's written. It's a minus and then x plus 3. That way you can see that it is a left 3. It's the opposite. And then that negative right there flips it. Negative inside flips left. Negative inside flips left. So basically if we went up 4, left 3, but instead of going this way, we flipped and we go this way. And the vertex is left 3, up 4, so negative 3, 4. And now we're getting ready to see a whole bunch in a row that are going to be exactly what you'll see on your Kindle when you go to do these. The first 4 though, note one thing. These next 4 examples you're getting ready to see are all y equals, which means if you're doing them, you can use your graphing calculator. It's the next ones that aren't y equals that you're going to really need to have memorized. But we can do it without a calculator. That's kind of the whole point. Y equals the square root of 4x. Remember, a number right next to x is just going to change the shape slightly. I should still see a dot with a tail. Which one do we think it might be? B. That 4 just kind of changed the shape a little bit. It's the dot. Tail's over to the right. Pretty normal. The second one, that 2 inside just changed the shape slightly. I should still see the dot with the tail, but what happens with this? Just down 2. So we want to just drop down 2, and then do your dot with the tail there. Which one shows that?
D.
There it is. Just goes down 2. All right, now I got a negative. I got a negative outside. So I haven't moved the vertex at all. This negative outside just did what?
Flips it down.
Flips it down. So I should see the dot on the origin, but should be the exact opposite. Which answer do we feel best about?
B.
B is the only one. And the last one, I have a negative and I have a shift. This means you're going to go down 5, but then what's that negative do? Flips it down. So which one shows us down 5? B. And notice the shape's a little different because of the 4, but that's basically it. We're here. And if you kept drawing, it would look like this. It just kind of didn't keep drawing that. And then C, no. D, no. So, y equals the square root of x. Pretty simple. It's a dot with a tail. Be able to move it left or right, up or down. Let's look at the one that you can't do on your graphing calculator, though. X equals the square root of y. And some of you guys who worked ahead, we kind of had to think through this a little bit. I showed you a few different tricks. I think this is going to be the easiest way to do it. Here's the parent graph. If you have a square root of y, you're going to have that same dot on the origin. But instead of tailing like this, you're actually going to tail like this, like half of a parabola, going up to the sky instead of going out to the right. So going up like that. That's what your square root of y looks like. So there's your basic square root of y. Now the negative and these top 2 are the only ones you really need to know for this objective. The negative actually flips it this way. So there's your square root of y, and here's your negative square root of y. So if you just know what a square root of y looks like, and you know what a negative square root of y looks like, you're going to be just fine. Now just for fun, if you put the negative inside, that makes it go down. That flips this down. Flip down, I'll put flip left over here. And if you got inside and outside, flip down and flip left. So it ends in the third quadrant here. I didn't do that right. You gotta go this way. Gotta go this way. Just kind of the way it arcs is going to be a little bit important. You're going to see here in a second. But for all that we're concerned is just know when it goes up and to the right, and when it goes up and left, positive and negative. Here's our two examples. I've got y equals square root, or x equals the square, x equals 8 square root of y. This I can't put in my calculator because it says x equals, but it's square root of y, so which one do we think it is? It's actually going to be C. The way that it arcs, how it starts here. That the only reason it's kind of wide is because of the 8, but it's like this there. This one's arcing up and right, but it's going to flatten more out to the right. We don't want that. And if you got negative, so you got x equals the negative square root of 4y plus 3. Most important thing is that the negative flips it toward me. So which one has it coming toward me and going up? And then that's D. And then that 3, it doesn't quite look like 3, but actually that plus 3 comes into play right here. That's what's saying that it's starting here at 3. More importantly is if you just had this shape. And that's it. You know what parabolas are, and you know now what the square root looks like. How do you move a shape up or down, though?
You put a number out to the very right.
A number out to the right. Jacob, a number out to the right is going to move you up and down. What kind of number moves you left or right?
A negative. No.
Well, what number? Where does the number go if it moves you left or right?
Or in the parentheses.
In the parentheses, or in this case, under the root. Inside is going to move you left or right. Outside is going to move you
I've got a room in my mind.
up.